binary subtraction. As we did with the addition, the binary addition, we want to start giving an example on how we perform subtraction for decimal numbers. All right. So remember, we call now the minuend and the subtrahend, and the result is going to be what? The result is going to be the residue. And we're going to do minus. Okay, how do we start? Exactly as we did with the addition. We go to the rightmost column, and then we start subtracting 5 minus 8. Wow, at this point, we have to think 5 minus 8, I'm subtracting a larger number than a small number. Okay, so it's 5 minus 8. I can't do that unless I have the amount to get the subtraction done. So I have somehow to borrow. Okay, borrow means that I have to go to the next column to the left and tell these guys, say, I need one of your units that when you pass that to me converts into 10 of my units so that I be able to subtract 8, right, from me. And that's what happens. So with the borrow, this column, the second column, will obey that and say, okay, I don't have at this point, but this is not a problem for now. I give you my units, and then you convert that as 10 units. Now I have 10 plus 5 is going to be 15. Now 15 minus 8 is possible to subtract, and I get 7, right? Good. Now the next column is almost in the same situation. You see, somehow this guy lent to the column to the right 1 unit, right? But at this point, he doesn't have anything in there. So he has to borrow from the column on the left, which is the one with the 2, right? And what happens then is that the 2 is going to be moving 1 unit to this column, right? And that converts into 10. But remember, we have another situation. We already lent 1 unit to the column on the right. And therefore, this is the situation for the second column. Okay, I got 10 units, but out of those 10, I lent 1 to my brother 5 on the right. And then all we have is 9. From 9, I subtract 1, and this is what I get. And finally, you see that the 2 that move 1 unit to the right, to the 0, because the 0 requested that, well, now it's kept only with 1 unit. Okay? So and that would be 1 minus 0, because there's nothing there, nothing here. It's going to be 1. Okay? So see, the thing here is to understand how the borrow work. So see, in this case, the borrow was moved from left to right. The first time, this rightmost column didn't have enough to perform the subtraction, had to borrow, and then somehow the column in the middle moved 1 unit to this column, and that was converted into 10. And the same thing happens here. But intermediate, we have this situation in the column in the middle lends some, but also has to borrow something from the column on the left. All right, so this is the way the borrow moved, and then therefore at this point, this column in the middle not only lent but also has to borrow, and at the end it just stays with 9 at the end, and then move that to the rightmost column. So there's an explanation in the book that I'm going to bring it to here with the same example. This is an example from the textbook, which is a really, really good explaining how the borrow works. So this is a number 205 minus 18. Say we're going to be using polynomial representation to understand that and to figure out how everything works. So the 205 is explicitly converted into a polynomial. Well, not converted, but represented as a polynomial. Okay, we know how to do that. This is the coefficient 2, the power of 10 to the second, and this is the second coefficient with 0 and 5. And the same thing we do with the 18. Okay, now, perfect. But see what happens. First, the first thing is that realizing that this number per se is not capable of sustaining the subtraction of 8 units. Therefore, he has to borrow from this column, which initially has a 0, and you need to subtract a 1 minus whatever number it is. If it is 0, well, that's what it is. We'll see next how we compensate that. Okay, now this flow here shows how then the rightmost digit, the 5, now gets 10 more units, and the column with the 0 is 1 less than we had before. Okay, and we keep this the same. I'm not messing with 18. Now at the end, what's going to happen? Because here's a deficit, I need to borrow something. And when I borrow from the 2, this is straight. I'm taking 1 from 2. But here I'm adding 10 to this coefficient that was minus 1. Okay, 0 minus 1 is 1. So at the end, I'm going to get exactly this. 10 minus 1 is going to be 9, and that's what I subtract from the 1, which is 8, and then here at the end is 15 minus 8 is going to be 7. And then the leftmost, or the highest power, is also 1 less because it borrowed. So it is extraordinary how this example explained the borrow. As you can see, subtracting is more complex than adding. Adding is straightforward. You can have a carry, and the carry is going to be always 1 if it is. Here, it could be a different type of numbers that I get when I borrow. All right. Let's see the rules in binary. Okay. So the rules are the following. If you subtract 0 minus 0, of course, it's going to be 0. If we subtract 0 minus 1, what is the situation here? Well, somehow, this is the case of the column in the rightmost, or the column in the middle from the example that we checked. And we know that this is not sustained by the operation. So we need to borrow 1 from the next. And then when I have a borrow, I'm borrowing 1. But see what happens. That 1 is going to be converted into what when it passes the amount to the right? What would be the amount? Well, it's going to be a complete value of the radix. In this case, we're passing 2. Now we have 2 minus 1, right? It's going to be 1. So remember, when you have the borrow here, all you have is a 2. Now the other case is 1 minus 0, of course, is 1, and 1 minus 1 is going to be 0. Okay? So keep in mind this. Similarly, as we explained in the addition, for sake of design in the future, arithmetic circuits, we want to look into how we approach that. And in the future, you see that we have one plan for the rightmost column, and we solve that with a straight half subtractor. Okay, it works okay only for the rightmost column, in which we don't have any borrowing. Okay, so this is all the rules that we already seen. 0 minus 0 is 0, 0 minus 1 is going to be 1, and with a borrow of 1. And these are 1 minus 0 is going to be 1, and 1 minus 1 is going to be 0. In the last two cases, no borrow out. So the only one that generates a borrow is this one. All right, let's see now if we're going to implement columns in the middle. And now these columns in the operation that are in the middle, well, not any column could be but the rightmost. In this case, the situation may be that we have a borrow from the column that is adjacent to the right, and then we need to make a borrow to the left. So we have a borrow in and a borrow out. Okay, so of course the borrow in refers to the borrow that is requesting our friend or brother on the right column, adjacent right column, and the borrow out is the one that we need to request. Okay, that's an output. Say, hey, I need to cover this with, I need part of the money. See, so this is a set of rules more complete than the one that we have seen at the beginning, and all the options, all possible combinations are here. So we have all covering for possible numbers, combination of the inputs A and B, 0, both, 0, 1, 1, 0, and 1, 1. And each one with a different value of borrow in. So it's kind of natural thinking, well, if we have both in 0 and no borrowing, we know already that that doesn't generate any borrow, and the result is 0, right? 0 minus 0 is 0. If I don't have any borrowing, there's no problem. Now, if 0 minus 0 should be 0, but now I have the situation in which my right-hand column is asking me for 1. So in that case, what happens is that now I had to borrow, I had to lend to this column 1 unit, right? And so in this case, because of that, my output would be 1, and I need to borrow also 1. Okay? All right. Okay. Now, the same thing here. If A is 0 and B is 1 and no borrow, well, I have that explained. My situation, I have to do a borrow from my left side, and that result will eventually be 1, but I have to request something from my left side. Same thing here. Well, 0 and 1, but with a borrow 1, what's going to happen? Well, in this case, the 1 that I borrow, the 1 that I spend, and the net is going to be 0, but of course, I'm borrowing 1 to my left, and so on. So you can see that this is perfect. Now, the point is, how do we apply this? Okay, so all we need to do is just look in the situation that we have here, and then apply whatever situation is referred into this yellow part, which is the input. Right? So let's start with 1 minus 0. There's no problem. 1 minus 0 with no borrow. See, we have at this point, the result is going to be 1, and the borrow out is going to be 0. So no borrow out. Now, the next one is 0 minus 1. I don't have any problem with the borrow. 0 minus 1 and no borrow. Then I have to generate a borrow, and the result is going to be 1. You see, when I generate this borrow transfer 1 unit from this column to here, and now this become 1 0. Okay, 1 0. Careful, except binary. This is a 2. Remember, I move 1 unit from one column to the right, and that converts into a whole radix absolute value that is transferred to that column, right? So now, because I get 1 0, that is 2, and from 2 I subtract 1, I get 1, right? Now, what happens here? This is 1 minus 0, and this situation is 1 0, 1 0, and we have a borrow in, so that would be 1 0 1, and then the result's going to be 0 and the borrow 0. Of course, we know that this unit that we have here was completely transferred to the right column because it was linked. So now my 1 that I had is now 0. Okay, and is now 0. All right, now we have the situation. Of course, we didn't generate any borrow here. You see, this is 1 0 with 1, both are 0. Now 0 1, I have nothing like a borrow in, so this should be the situation, and then I have 1, right, with a borrow, and the borrow is signified like that. So that means that I pass 1 here. That's 1 converted into 2. Subtract 2 minus 1 is going to be 1. Right? Now, this position would be what? This position would be 0 minus 0, but I have a borrowing. So 0, 0, minus 1. You see this situation? And the result is going to be 1 with a borrow out of 1. And now, the last one is 1 minus 0 with a borrow in. And that would be 0 with a borrow in 0. Okay? So see that this intermediate got a 1 in this case. Okay? So this is pretty much the way in which we perform subtraction. As I said, it's a bit more cumbersome than addition. And you're going to see next that usually we get around the subtraction with some other mechanism, some other algorithm that it will be explained later. All right? All right. Next, we're going to be explaining the binary multiplication. I have to cut here because, well, it's 18 minutes of recording.